In this talk, I will present you with a software vision we call Shareable Dynamic Media and a system we have developed to explore and demonstrate the potentials of this vision that we call Webstrates. And the work presented here is done in collaboration with James Eagan from Telecom Tech, my PhD student Siemen Baader, and Wendy Mackay and Michel Beaudouin-Lafon from Université Paris-Sud in Inria. My name is Clemens Klokmose, and I'm from Aarhus University in Denmark. So, a bit over 40 years ago, Alan Kay, he imagined future computers taking the form of paper pad-sized devices he called Dynabooks. Interaction with these would happen through personal dynamic media that would let us mold and channel the power of the computer to our own needs, to paraphrase Kay. In Kay's vision, two children, Jimmy and Beth, were sitting in the grass and playing Space War across their linked Dynabooks. They found the game a bit too easy and started to collaboratively tinker with the program code to change the gravity on the ship to make the game more challenging. So in Kay's vision, software was an expressive medium that could be tinkered with and appropriated for personal and idiosyncratic needs and desires. Some 20 years later, Mark Weiser and his team at Xerox PARC built pad-sized computers. And Weiser envisioned that these would seamlessly work in concert with other kinds of devices, both large and small. Today, the hardware of Kay and Weiser's vision has largely been realized in smartphones, tablets, laptops, large displays, and that are all connected wirelessly together. Yet the software is not really there compared to the visions. Today's software is not really soft. Software is hard to change. We are mostly limited to predetermined lists of preferences, and even trained developers are at the mercy of application developers to provide hooks for adding or changing functionality. Being able to change the functionality of our tools or our games is the exception rather than the norm. Similarly, our digital documents that we work on today, in a broad understanding of what constitutes a document, they're quite easy to exchange. However, they're difficult to truly share. So cloud-based file synchronization struggle with editing conflicts, and real-time collaborative editors are limited to a few application domains, and they require users to migrate their documents from their familiar tools to a new environment. And sharing actual running application is close to impossible beyond bitmap-based screen sharing. So an integrated collaborative cross-device situation like the one on the picture to the right, or Jimmy and Beth's collaborative tinkering with the program code of a running game is still far from commonplace. We propose to revisit Alan Kay's idea of conceptualizing interaction with computers as being interaction with dynamic media. Now, personal has quite different connotations now than then, so to push for a focus on collaboration, distribution, and sharing, we refer to our revisit of the vision as shareable dynamic media. The vision of shareable dynamic media embodies three core properties of software: malleability, shareability, and distributability. Malleable software lets users appropriate and repurpose their tools and documents in personal and idiosyncratic ways. Shareable software allows users to seamlessly collaborate synchronously and asynchronously on any kind of data using their own personalized tools and views. And finally, distributable software allows tools and documents to span and move easily across different devices and platforms. We believe that the keystone in realizing this vision is to abandon the strict distinction between applications and documents. This distinction was not there in the beginning of interactive computing, but it's something that we have introduced later for convenience. And instead of talking about applications and documents, we have now talked about information substrates, or just substrates for short. We define shareable dynamic media as consisting of such substrates. And substrates are software artifacts that embody content, computation, and interaction. And they can act as an application in one use situation and a document or domain object in another, which you will see in a moment. So the web actually partially fulfills being shareable dynamic media. Web pages represent content that mixes text, images, interactivity, video, etc. in a platform-independent way. They are globally addressable by URLs, and content on the web is represented both in an easy-to-store and easy-to-share text format, HTML, and has a standardized runtime representation in the document object model, the DOM. And this DOM can be manipulated at runtime using JavaScript or inspected and edited directly through the browser's developer tools. However, in traditional web, this DOM is ephemeral, and local changes to the DOM do not persist, nor are they seen by clients of the same page. But what you see here is a web substrate, or a Webstrate for short. And a Webstrate is a web page where changes to the document object model of the page persists and is synchronized to clients of the same page. So in this setup, I'm using two computers, one that's showing the slides and the projector, and one where I have the tools for controlling the slideshow. That means that I can actually directly from my tool over here edit the slide like this, and it will update on the other computer. This slide actually also contains some JavaScript, and I can hover over the JavaScript over here so you'll see it. It's a very basic JavaScript that toggles a CSS class on the title on the page when I click it. What I'm going to do now is over here on my computer, I'll click it, and then it toggles a CSS class that will make it rotate. I'll go to this computer, toggle the same JavaScript, and it turns off the CSS class. Finally, I can also edit the Webstrate directly here through the DOM inspector. All right, and I'm just going to do something quickly because I see I have the wrong browser open. Just bear with me. Right. The principle of Webstrates is extremely simple. When a browser opens a specific resource URL on the Webstrates server, say my Webstrate, then the Webstrates client the Webstrates JavaScript client is loaded in the browser. The Webstrate client now gets the data of the Webstrate given by the URL and populates the DOM of the page based on the data. And now the client observes both local changes to the DOM and remote changes to the Webstrate from other browsers, including changes to inline style sheets and scripts. And now, this is also a Webstrate. This is our UIST paper loaded in a WYSIWYG-styled editor Webstrate. And this is the actual paper that we wrote collaboratively together and produced a PDF for the proceedings. And I can edit it directly here. Edit the text. In this paper editor, we are using transclusion of one Webstrate into another. And transclusion is an old hypertext principle that means the inclusion of part or all of an electronic document into one or more documents by reference. Now, when what we share is the DOM, all of the DOM and nothing but the DOM, transcluding a document into an editor becomes necessary to be able to edit it without having to put the tools directly into the document. And that's also the mechanism I'm using here to control the slides. So actually this iframe here is a link. When I click it, my slideshow editor is open. And that's what I'm looking at on my computer over here, where I have some tools for manipulating the slides. I have my notes, etc. I'll close that again. So what you're looking at is a browser on this computer pointing to my slides. And what I'm looking at this computer is a browser pointing to my slide editor that then transcludes the slide you're looking at. When using transclusion with iframes with pages that are served from the same domain, a two-way relationship is established where both transcluder and transcludee can modify the DOM of each other through scripts. So that's what we're doing here. I have script in my slide editor that toggles CSS classes on my slides when I switch slides like this. Now, CSS provides us with a separation between content and presentation. That means that from an editor Webstrate, I can apply new styles to a transcluded document. And you can see the mechanism here. To the right, you see an unstyled document. And to the left, we have an editor that transcludes the document in an iframe, styles it according to a reference style sheet, and provides various tools for marking up the text. And here in the abstract, I wrote some text, and I hit bold to boldface it. And you saw it updated. I'll just move this way. A document can be transcluded in multiple editors that allows for collaboration on the same document with personalized editors like here. So imagine we have Bob to the right, who prefers a WYSIWYG editor, while his grad student Alice prefers a single-column light-on-dark editor. And they can collaborate. So now Alice is writing in the abstract, or Bob is writing. Okay. So Alice can also use this mechanism to have a live print preview on her iPad while she works on the document in her editor on the laptop. And if they, for instance, have a figure in the paper, that can similarly be a transcluded Webstrate, and that enables editing this figure with different types of editors on different types of devices. So you see here I draw on the tablet while the figure updates in the paper on the iPad, and then I go to my laptop and do some SVG editing on the laptop of the same Webstrate that is transcluded into the paper. This is Alice's editor from the video before, and this editor is not only visually different from Bob's WYSIWYG editor, but it's also functionally different. Alice has a tool for handling citations, which means that I can go down over here, write a keyword, I'll write visor, select it, and hit the cite button up here. And now a reference is added to the paper, and it's added down here in the list of references. Now, this particular tool uses another Webstrate that's transcluded in an iframe, but this iframe is hidden with the bibliography, and I can click a button here to open it. And that's just a basic web page that allows for importing BibTeX into an HTML format. Now you could imagine that Bob, he would be interested in having this tool as well. So imagine that Bob, he's not super technically savvy, so he asked Alice to install the tool for him. And here you see to the left you have Alice's computer, and to the right you have Bob's computer. So what you'll see now is that Alice extracts a snippet of code representing the tool, opens up Bob's editor on her computer, presses a plus button, pastes in the text, and now the tool is immediately usable for Bob. So what you just saw here was collaborative runtime extension of a user interface. And that's possible because the editor is also a Webstrate, and therefore it's malleable. And Alice can edit Bob's interface remotely while he's using it. So creating Webstrates is very similar to traditional web development with HTML, CSS, and JavaScript. However, it's quite different from building modern web apps, as it does not require dealing with a backend or complex logic to render content from a database to HTML. So from the perspective of the developer, there's no backend, just a persistent material that you manipulate directly in the browser. This also means that it affords a new set of design patterns compared to traditional software development, which we see slowly emerging when we are developing with Webstrates. For example, this is the DOM architecture of the editor from before. The document is a transcluded Webstrate in itself here, and the tools, including the toolbar itself, are also included using Transclusion, but the iframes are hidden. So in the editor DOM, each tool consists of what we call an instantiation element, for instance, the div here with the cite tool, and that contains of a transcluded Webstrate containing the code of the instrument, and it also contains this transclusion of what we call the bibstrate, the bibliography. And it's the serialization of this guy here that Alice copied between the editors. Tools in the paper editor are implemented following the principles of instrumental interaction. Each tool or instrument can operate on domain objects with certain well-defined properties rather than being confined to the enclosing application, as in current systems. They are independent objects that can be moved, copied, and shared. In Webstrates, the logic of each instrument can reside in its own Webstrate, which therefore can be shared between editors through transclusion. And now instruments are applicable where they make sense. So I can actually use the citation instrument I had from before here from my slide editor. So I can write Beaudouin 2000, and now I'll select it here and hit the cite button, and then a reference was added to my slide. It's the same tool I use on my slide as I use on my document. All right. Behind the scenes, synchronization in Webstrates is based on operational transformation on the DOM using an open source OT framework called Share.js. Share.js works on JSON, so we represent and install the DOM in JSON-ML. To observe local changes to the DOM, we use the modern Mutation Observer API. And the server is around 300 lines of CoffeeScript, and the client is around 800 lines of CoffeeScript, both excluding third-party libraries, so it's relatively simple. The current implementation of Webstrates is a proof of concept, but it's also a usable software framework that we have used to write the software for writing the paper together, and that I'm using software also for writing the software that I'm using right now. And in the paper, dedicate a section to evaluate it as an actual user interface software framework. There are some limitations. It relies on a centralized server. There are a number of performance optimizations that can be done. The synchronization algorithm is not 100% bulletproof, and we only have a very rudimentary access control scheme. And from the user's perspective, managing Webstrates is a bit laborious, and we currently have no general mechanism for supporting user awareness when collaborating. But that's all points for future work. I think I have time for a quick final example. So what you see here is a Webstrate that has other Webstrates open in Windows through the use of Transclusion. So I have a window manager running here on my slide, and from my computer over here, I can move the windows around, and I can go to the other computer here, and move them around as well. And what I have here is I have a to-do list of what I have to do today. And here I have a code editor. And this code editor is a bit special because it opens up another Webstrate through Transclusion, and then it makes me be able to edit the script and style tags. And I will just do that quickly. So I open up and this one points to the window manager itself, which means that if I write orange here, then I change the CSS of the window manager. And I go over here to the other computer, and I'll write pink. All right. So now I can do like this. So in this talk, I've presented a software vision we call Shareable Dynamic Media that advocates for malleability, shareability, and distributability of software as the norm rather than the exception. The vision advocates to abandon a strict distinction between applications, and I've presented a system, Webstrates, to demonstrate this vision in practice. And if this talk has piqued your interest, you can find paper, videos, link to code, and tutorials on webstrates.net. And if you're interested in working on this project, my co-authors in Paris have funding for continuing this work. So, thank you.
Hi, Mike Terry, University of Waterloo. So super cool stuff. You mentioned security in that one future slide, and so I'm trying to wrap my head around what parts might be sandboxed and what parts are not sandboxed in terms of code execution.
Yeah, regarding security, I might tell you a quick anecdote, because I was doing a presentation of this to some people in the US, and I sent them a link to my slides, like you see here. And then there were 15 people opening up these slides on each of their computer, and the poor Japanese intern had malware in his browser that injected a script into the slides that got distributed out to all of the other 15 computers and started injecting ads into the slides. And this was kind of unexpected for me. So there's a lot of security issues. Also with the transclusion mechanism. For instance, if you transclude something in, it actually has access to the runtime of the transcluder. And there are some sandboxing mechanisms you can use in the browser, but they're kind of a bit too coarse still. What I've done now to avoid that the script injection happens again is that I have a basic authentication mechanism where I can annotate certain Webstrates with user privileges like read and write, etc.
Thanks.
Hi, Gilbert Bernstein. Thanks for the talk. Looks exciting. I have a variation of sort of the same question about security, which is it seems like part of the motivation here is to tear down some of the distinctions between code and data, and that seems like an extremely useful distinction for security properties, because of course we can do a lot to make various forms of data not be security problems by not letting them run arbitrary code.
Right.
Have you thought about it from that angle, security in particular, or whether or not that presents any challenges to sort of the underlying motivation for the work?
It definitely presents challenges, and I don't think that we have solved the challenges of scaling, for instance, to being able to have publicly available Webstrates online. But at the same time, we are really interested in also the potentials of dissolving this distinction between documents and applications. So security has been secondary to us, but it's definitely, if it's something that has to be picked up and used by real users in production environments, it's a problem that has to be solved. So if any one of you is really interested in working on this, please let me know.
So I really like that this framework has an opinion about how web applications should be built. In particular, it's synchronizing the entire DOM relative to things like Meteor, which really are about sort of a model view controller kind of view of the world. And I'm wondering if you were to get it, sort of stand up on your soapbox for a minute and explain the scenarios in which you think this opinion or this point of view is particularly well suited, as opposed to something like an MVC framework. What would you say? Like, what is like the real?
It's particularly suited when you're working with something that can be thought of as documents, and in a very broad understanding of documents, and where you want people to be able to collaborate on these documents with their own tools and their own ways of seeing the document. So we had this simple example of Alice and Bob that had each their own editors. So that's one of the core things, because then the coupling between how you interact and how you see a document isn't a hard coupling as it is, for instance, with Google Docs, but it becomes something that you can personalize. And there's probably more things you can do, but that has been our core focus of this one.
Thanks. I look forward to seeing it competing in the browser framework wars.
Thanks.